Okay, so we do 15.3. So we are given a demand function P equal to P0 minus P1 times QF, and a total cost function CF equal to C0 plus C1 QF plus C2 QF square. Okay, so part A asking you to obtain the firm's marginal and average cost function and its total marginal and average revenue. Okay, so marginal cost is just going to be the differential of the total cost function with respect to quantity QF. Okay, so if I differentiate this cost function, C0 will become 0, C1 QF is C1 and plus 2 C2 QF. Okay, average cost is going to just be so marginal cost F, average cost F, it's just going to be the total cost function CF divided by the total quantity QF. So that is going to give me C0 on QF plus C1 plus C2 QF. Okay, and the total marginal and the average revenue. So we find the total revenue first. So total revenue F is going to be equal to the price P times quantity QF. Okay, now the price P is given by the demand function, which is equal to P0 minus P1 QF and everything multiplied by QF. Okay, so if I expand the bracket, I got P0 QF minus P1 QF square. So that is my total revenue. Now marginal revenue is going to be just the differential of the total revenue function with respect to quantity QF. Okay, so if I differentiate this, I'll get P0 minus 2 P1 QF, and that is my marginal revenue. Now average revenue function is just going to be the total revenue function divided by the quantity QF. And so that will give me P0 minus P1 Q1. Okay, so part B asking you to calculate the profit maximizing level of output and the price that the firm will charge and the profit that it will make. Okay, so the only thing you have to remember is the profit maximization condition for the firm. Is where the firm is going to produce at the point where marginal revenue is equal to marginal cost, okay, for the firm. So in this case, we have already found that marginal revenue is P0 minus 2P1 times Q, and we also found that marginal cost is C1 plus 2C2 QF. Okay, so if we are solving this equation for Q, then we should be able to find the optimal amount of quantity that the firm is producing to maximize the profit. Okay, so if I move this to the right hand side, so I got P0 and I move C1 to the left hand side, become negative C1 is equal to 2 P1 QF plus 2 C2 QF. And so therefore P0 minus C1, if I take 2 QF outside the bracket, inside I got P1 plus C2. And so therefore QF is going to be equal to P0 minus C1, everything divided by 2, P1 plus C2. Okay, so this is my optimal quantity that the firm is going to be producing. Now, so what is the price that the firm is going to charge? So if you substitute the optimal quantity into the demand function, then you'll be able to find out the price that the optimal price that the firm will be charging, which is equal to P0 minus P1 and QF. Okay, so that is P0 minus P1 times P0 minus C1 divided by 2 P1 plus C2. Okay, now to find the firm's profit, we just have to take the total revenue minus the total cost. So firm's profit is total revenue minus total cost. Okay, so we found total revenue earlier, which is over here equal to P0 QF minus P1 QF square. Okay, so P0 QF minus P1 QF square. And the total cost function is given to us equal to C0 plus C1 QF plus C2 QF square. Okay, so if I expand the bracket and simplify, I'll get P0 QF minus C1 QF, and that will just give me P0 minus C1 everything times QF. I got P1 QF square and minus C2 QF square. So if I take negative, that will give me P1 plus C2 QF square. Okay, and so I got negative C0 at the end. Alright, so knowing the values of QF star that we found earlier, I would just have to substitute into here to find the firm's profit. Okay, and so that would just be equal to so P0 C1 times, so QF is P0 C1, sorry, P0 minus C1 to P1 plus C2 minus P1 plus C2 QF square, which is P0 minus C1 square, and everything divided by 4 P1 plus C2 square. Okay, and minus C0. So now I just have to simplify this. So this will give me P0 minus C1 everything square divided by 2 P1 plus C2, and this P1 plus C2 will cancel with one of the P1 plus C2 on the denominator, so that will just give me P0 minus C1 everything square divided by 4 P1 plus C2, okay, and minus C0. So this simplify this, I will just get so this minus this will just give me P0 minus C1 everything square divided by 4 P1 plus C2 and that is minus C0. Okay, so this is the firm's profit, the firm maximum profit when the firm is producing at the profit maximizing level of output. Alright, so part C is asking you to sketch a diagram showing marginal cost, average cost, marginal revenue, and average revenue, and indicate profit maximizing output, the price and the profit on a diagram. Okay, so I will just have a normal diagram over here, where over here I will just have so that is marginal cost, average cost, marginal revenue, and average revenue for the firm, and over here I will have the total quantity QF. Okay, so average, so the marginal cost we found earlier, which is here, okay, is C1. So the first one is marginal cost, which is C1 plus 2 C2 QF. So as you can see, this is just a straight line because this is just a linear function of QF. Okay, so a straight line with a vertical intercept of C1 and a slope of 2C2. So we know that it's going to be increasing. Okay, so to draw a straight line, the easiest way is to just find a horizontal vertical intercept, or you can just pick any two random points and connect those 2 points together by a straight line. Okay, so I will say now vertical intercept is where I make QF equal to 0. Then marginal cost is going to be equal to C1, so I know that C1 is vertical intercept. Okay, so I will just put any random point, say this over here, C1. Okay, now so horizontal intercept is where I make, or I just get another random point, and in this case, because I do not know the values of C1 C2, so an easiest way is just draw a straight line starting from the vertical intercept going all the way up like this. Okay, and we know that the slope of this one is just going to be equal to 2C2. Alright, so this is the marginal cost. Alright, and the slope is 2C2. Okay, so the next one is the average cost. So average cost for the firm is just going to be equal to C0 on QF plus C1 plus C2 QF. Okay, so now, so as you can see, when Q, so as you can see, when Q is going to 0, then the whole function is going to infinity. So we know that it is approaching the vertical intercept. Okay, so when QF is approaching 0, then average cost is approaching infinity. So we know that it's going to be tangent to, not, it's going to be approaching, so getting closer and closer to the vertical intercept. Okay, so I'll say approaching the y-axis. Okay, and now we just have to come up with a few more points, and then we should have a rough idea. Okay, so the second thing we would like to do is to find the minimum or the maximum point, okay, which is a stationary point. So by doing that, we should be able to see roughly how the graph is going to look like. So we find a first order condition where we differentiate the average cost function with respect to QF and make it equal to 0. Okay, so if we differentiate this, we get negative C0 on QF squared. Now, if anyone who doesn't know how to get this, you basically C0 on QF is just C0 times QF to the power negative 1. Okay, so using the power rule, you should be able to get something like this. And differential of C1 is just 0, and differential of C2 QF is going to be C2. And I would like to make this equal to 0. Okay, so therefore, solving this equation, I will get C0 on QF squared equal to C2, so therefore QF squared equal to C0 on C2, and so therefore QF is going to be equal to the square root of C0 on C2. Okay, so again, to see whether this is a minimum or the maximum point, I just have to find the second order conditions where I differentiate the first order condition again. So remember, this thing, you just basically treating this as negative C0 times QF to the power negative 2. So if I differentiate this thing again, I'll get negative C0 times negative 2 QF to the power negative 3. And differential of C2, which just becomes 0. Okay, so this whole thing over here is just 2C0 on QF to the power 3. And so given that QF is positive, then this thing is going to be positive. Okay, so for any QF positive. So if a second order condition is positive all the time, then we know that the QF we found over here is a minimum point. Okay, so QF equal to C0 on C2 is the minimum point. Okay, so if I substitute the value of QF back into my average cost function ACF over here, I will be able to find the minimum value of the average cost. Okay, so the average cost F minimum is going to be equal to C0 divided by QF, which is square root of C0 and C2 plus C1 plus C2 times square root of C0 and C2. Okay, so if I simplify this, it will just give me, so this is C0 times square root of C2 on square root of C0 plus C1 plus C2 times square root of C0 divided by square root of C2. Okay, so C0 on square root of C0 is just square root of C0. So that will just give me square root of C0 times C2 plus C1, and C2 divided by square root of C2 is square root of C2 times square root of C0, so that will give me square root of C0 times C2. So I got 2 square root of C0, C2 plus C1. Okay, so on a diagram, I do not know the exact value of these because I do not know the values of C0, C1, and C2. However, I know that this point is going to be above C1. Okay, so it's going to be bigger than C1, so it's going to be somewhere above C1. So for example, I'll just pick a random point, say here. So this is 2 square root of C0, C2 plus C1. Okay, and as you can see, it is obviously above C1 because it is C1 plus something positive. Okay, something non-negative. So therefore, it's going to be above C1. Alright, now another thing, if you pay attention, I already have been mentioning this, now marginal cost curve is always going to go through the minimum point of the average cost curve. So therefore, we know that if this is the minimum point of the average cost curve, where Q equal to square root of C0 and C2, then the marginal cost curve is going to go through this point. Okay, so in order to check this, if you are substituting the value of QF, which is equal to square root of C0 and C2, back into the marginal cost function, then you find that the marginal cost is going to be equal to the value of the average cost at the minimum point. Okay. Okay, so I'll say okay, so if I substitute the value of QF equal to square root of C0 on C2 into the marginal cost, then I'll find out the marginal cost F is going to be equal to C1 plus 2C2 times QF, which is C0 on C2. And so it's going to give me C1 plus, now C2 on square root of C2 is square root of C2. So this will give me square root of C0 times C2. And as you can see, it's exactly equal to this average cost minimum. Okay, so we know that at this minimum point, the average cost is going to be equal to the marginal cost. Okay, so therefore, when you draw a diagram, you have to make sure that the margin, this point is also lying on the marginal cost. So therefore, this is going to be the minimum point where Q equal to square root of C0 and C2. Okay, so that is how you draw it. Okay, we do not know the value of all of these, however we need to know all of the properties. Okay, so in order to draw it precisely, so we know that it's going to go through, so this is the minimum point on the average cost curve, and it also lying on the marginal cost curve. Okay, so when you draw a diagram, now it should be straightforward, that we know Okay, so we know that it's going to be approaching the vertical axis and it's going to have a minimum point at this point over here. So when you draw a diagram, it's just going to be like this. Okay, so this is my average cost curve, and this is the minimum point of the average cost curve. Okay. Alright, so the next one is the marginal revenue and the average revenue. Okay, so the marginal revenue we found earlier is P0 minus 2P1 times Q. Okay, so P0 2P1 QF. Alright, so again, as you can see, this is just a linear function of QF, so therefore it's just going to be a straight line, okay, with the vertical intercept of P0 and the slope of negative 2P1. So it's going to be a downward sloping line with a slope of negative 2P1. Okay, so this is the vertical intercept, and this is the slope of the line. Okay, so when you draw a diagram, it's just going to be okay, just going to be having a vertical intercept of P0, so I would assume that is just somewhere over here. Okay, now I do not know the exact value, but I would just be assuming that it is something like this. Okay, so outside this is marginal revenue F. Okay, so the slope of this one is negative 2 P1. Alright, and so the last one is the average revenue, where is equal to P0 minus P1 QF, okay, which is what we found earlier. Now here, okay, again, as you can see, this is just a linear function of QF, so again it's just a straight line with the vertical intercept of P0, which is exactly the same as the vertical intercept of the marginal revenue, and the slope of negative P1. So again, it's downward sloping, and as you can see, the slope of this is just half of the slope of the marginal revenue. Okay, so therefore average revenue is going to be flatter, and the slope will just be half of the slope of the marginal revenue. So in terms of a diagram, it's just going to be starting from the same vertical intercept and having half of the slope. Okay, so this is the average revenue curve with the slope of negative P1. Okay, so as you can see, it is twice as flat as the marginal revenue because the slope is half of the slope of the marginal revenue. Alright, so indicate on the diagram the profit maximizing output and the price and the profit. So the profit maximizing output is where the marginal revenue equals the marginal cost. So I got marginal cost line is here, marginal revenue is here. So this point over here is going to be the profit maximizing point. Okay. Okay, I'll use a green point. Okay, so the profit maximizing point is where marginal revenue is equal to marginal cost. Okay, so that is the point where the profit is maximized. So what is the price? So this is the quantity QF star at which the profit is maximized. Okay, and as we found earlier, that is going to be here, alright, which is P0 minus C1 divided by 2 on P1 plus C2. That is the optimal quantity that is maximizing the profit. Okay, and the price corresponding to this quantity. So if you are going to find a price, then we know that the price is going to be equal to P0 minus P1 times QF. Okay, and as you can see, it is exactly the average revenue, which is here. Okay, now this is equal to the price function, okay, which is P0 minus P1 times QF. So the average revenue is basically just the price curve. Okay, so this is the same as the demand curve, which is telling you about the price. Okay, so therefore, in order to find the optimal price, then you just have to go all the way up to the average revenue curve at this quantity, and so this is going to be the optimal price that is maximizing the profit for the firm P star. Okay, and so okay, so this at this quantity over here, now this is the price per unit that the firm is going to charge. Now at this, with this quantity corresponding to the average cost function, this is going to be the cost for the firm, okay, which is the average cost for the firm, which is the cost per unit. So the difference between, so this is average cost star, so the difference between the price and the average cost is going to be the profit per unit for the firm. Okay, so remember, the firm's profit